Hello everyone, welcome back to my channel Explain Maths. So in this video, I'm going to start with a new chapter and the name of the chapter is Factorization. And in this video, I will be covering the introduction of the chapter Factorization as well as I will be solving the questions of exercise 12.1. So let's begin the class. First of all, we will see what do you mean by factors. So suppose I have taken a number 12. Okay, so if I have to find the factors of 12, it means we have to find the number which can divide this 12 completely. Okay, so first of all, we will see in one table 1 times 12 will give me 12 and 12 is divisible by 1 also, 12 is divisible by 12 also. So I can say 1 and 12 both are the factors. Now next 2 times 6 also gives me 12. So if I divide 12 by 2, again I will get remainder as 0, and if I divide 12 by 6, again it will be 12 will be getting divided by 6 completely. So I can say 2 and 6 are also the factors of 12. Same way 3 into 4 also gives me 12. So 12 will be divided by 3 and 4 also completely. So from here I can say that this 1, 2, 3, 4, 6 and 12, they all are the factors of 12. And these numbers 1, 2, 3, 4, 6 and 12, if you divide 12 with these numbers, the remainder will always come 0. So that is the meaning of factors. Now next we will see how to represent 12 as a product of the prime factors. Okay, so to write the prime factor of 12, I can write it as 2 into 2 into 3. And if you multiply, 2 into 2 is 4, 4 into 3 is 12. And here 2 and 3 are prime numbers. So this is the, in this way we can represent the prime factor form of 12. So similarly, we can express algebraic expression also as the product of their factors. So we will see how to represent algebraic expression as the product of their factors. Use of algebraic expression. So this is my expression 7xy. So here if I am going to write in terms of the factors of this, so it will be 7 into x into y. And if you multiply 7 into x and y, you will get 7xy only. So from here I can say that 7x and y, they all are the prime factors of 7xy. Or we can say that 7 into x into y is the irreducible form of 7xy. What is the meaning of irreducible? You cannot further reduce it because 7 is a prime number. Okay, you can't reduce it further. So this is the irreducible form. So in algebraic expression, we will not write that they are the prime factors. Instead of that, we will use the term irreducible form. We cannot further reduce it. Okay. Now let's take another expression 6y into x plus 2. So 6 I can write as 2 into 3, y multiply by y and then multiply by x plus 2. So this is my irreducible form of this expression. So we can say 2, 3, y and x plus 2, they are irreducible factors. We cannot further reduce it. 2 and 3 both are prime number. We cannot reduce it further. So when we factorize an algebraic expression, we write it as a product of factors. So you can say here 2, 3, y and x plus 2, they all are the factors of this expression 6y into x plus 2. These factors may be numbers, it can be algebraic variable or it can be algebraic expression also. So if you see in this example, 2 and 3 are numbers, y is the algebraic variable and x plus 2 is the algebraic expression. So factors can be any one from these three. So what do you mean by factorization? The process of finding two or more expressions whose product is the given expression is called as factorization. Okay, so if you see the expression like 5x plus 20, 3x plus 3y and x square plus 5x. Here in these three expression factors are not very clear, isn't it? So we have systematic method to factorize these expressions. So there are so many ways to factorize it. We will do each method one by one. So now the first method is method of common factors. So here I have taken expression 5xy plus 10x. So let's find out the common factor. So I am going to write 5xy as 5 into x into y plus 10 I can write as 2 into 5 into x. So I have written both the terms as an irreducible factor, isn't it? 5x and y are the irreducible factor of 5xy and 2, 5 and x are the irreducible factor of 10x. Now if you see in both the terms, what are the common factors? So you can see here 5 is common in both and x is common in both, right? So your common factor is 5x. And if you take 5x common, in the first term you are left with only y, and in the second term you are left with 2. So this is the factorization of the expression 5xy plus 10x. Okay, and if you multiply it again, you are going to get 5xy plus 10x only. Now let's see another example. 12a square b plus 15ab square. So here if I am going to write 12a square b as 2 into 2 into 3. So 2 into 2, 4, 4 into 3 is 12. A square will be A into B plus 15 I can write as 3 into 5 into A into B. Now let's see what are the common factors in both the terms. So we can see 3 is common in both, then one of the A is common in both, and then one B is common in both. So I can take the common factor as 3AB. So from the first term, if I take 3a and b common, I will be left with 2 into 2, 4, 4 into a, which will give me 4a, isn't it? And from the second term, if you take out 3ab as a common factor, 3ab, I have already written the common factor here. So I will be left with 5 into b, which will give me 5b. So this is the factorization of the given algebraic expression. Now this is the first method. There is one more method which is known as by finding out the HCF of the both the terms. HCF means highest common factor. So if you see for 12 and 15, the highest common factor of 12 and 15 is 3. 3 table only. 3 is the highest common factor in which both 12 and 15 comes. So from here I can write one of the common factor for both is 3. Now next we have to find the highest common factor of the variable also. So highest common factor of the variable will be the variable having the lowest power. So if you take the variable a, here it is a square, here it is a. So the lowest power of a is 1. So the common factor of the variable a will be a only. Same way if you see the next variable is b and the lowest power of b is 1 in the first term. So b is also a common factor. Now you have taken 3ab as common. Now if you see the first term, here it is 12a square b. So in 3, how much you will multiply to get 12? So you know that 3 times 4 will give me 12. So here it will be 4, isn't it? Now if you see in the term, it is a square, but you have taken only one a as common. So it means one a is still left. So it will be 4a. Okay. Now if you see the second term in 3, how much you will multiply to get 15? It will be 5. Okay, the variable a is already you have taken common. This a is already common. Now here it is b square and you have taken one of the b common. So you are left with 1b. So this is also one of the way to factorize it. Okay, this will be more fast method where you have to find the HCF and you have to do it. Now let's take one more example. Here it is 10x square minus 18x cube plus 14x to the power 4. Now let's find the highest common factor of 10, 18 and 14. So if you see both, all the three are even numbers. It will come in the table of 2. Isn't it? 10 comes in, 10, 18 and 14, all three comes in the table of 2. So their highest common factor is 2. Now variable x is present in all the three terms. So to find the HCF of the variable, you have to see the variable which is having the lowest power. So lowest power of x is 2. So I can say x square will be common factor. So from here you can see 2x square is a common factor. So first term if you see it is 10x square. So in 2 how much you will multiply to get 10? So it will be 5 and already x square you have taken common. Now next in 2 how much you will multiply to get 18? It is 9 and the variable x is having power 3 and you have taken x square as common. So it means one more x is still left. And the next is 14. So 2 times 7 will give me 14 and x square you have taken common and in the third term it is x to the power 4. It means x square is still left. So this is the factorization of the given algebraic expression. So hope it will be clear. You can do using any method. I have given both the method first by expanding in terms of irreducible factors and then taking out the common factor, or you can find the HCF of the number and the HCF of the variable. And like that you can take the common factor and you can solve it. Now I'm going to solve the try these question given in page 147. So the question says you have to factorize it. So the first expression is 12x plus 36. So if you can see here, this 36, it comes in 12 table. So I can say the highest common factor of 12 and 36 is 12 only. So I can take 12 as common, and variable x is present only in the first term. So variable is not common. So I can write here 12. So if I take 12 common from the first term, only x will be left. And in 12 table, 12 times 3 will give me 36. So the answer is 12 into x plus 3. This is the factorization. Now next is 22y minus 33z. So 22 and 33 both comes in 11 table. So I can say the highest common factor of 22 and 33 is 11. And the variable y and z both are different variables. So I can't take anything common over here. So the common factor is only 11. And in 11 table, when 22 comes, 11 times 2. So it will be 2y minus 3z. 11 times 3 will give me 33. Now next, in the third question, 14 PQ plus 35 PQR. Now if you see 14 and 35, so what is the highest common factor of 14 and 35? In which table you can see 14 and 35 both comes, and that should be the highest factor. So I can say 7 is the highest common factor, because in 7 table 14 also comes, 35 also comes. Now, if you see the variable, in the first term also variable PQ is there, in the second term also variable PQ is there. So from here I can write one of the factor will be 7, and in variable the factor will be PQ. So in 7, how much I will multiply to get 14? So it will be 2. Already PQ I have taken common. And in the second one, 7 times 5 will give me 35. And PQ is already taken common, so only R will be left. So this is the factorization of the given expression. Now, another method of factorization is factorization by regrouping terms. Now, first we will see what is the meaning of regrouping. So, regrouping means arranging the terms in the given expression in groups in such a way that all the groups have a common factor. So, sometimes what happens, if the expression is having suppose 4 terms, we will not able to find any common factor which will be present in all the 4 terms. Like I have given this one example, 2xy plus 3x plus 4y plus 6. You will not able to find a common factor which will be present in all the 4 terms, isn't it? So in such a case, we have to make a group of it. So if I'm going to make a group of the first 2 terms, I can see my x is common. And if I'm going to make a group of the last 2 terms, I can say 4 and 6, the common factor is 2. The HCF of 4 and 6 is 2. So if I'm making 2 groups here, I am able to get the common factor. So what I will do, I'm going to write it as, I will take here x common. So it will be 2y left. From here if I take x common, I will be left by 2y. And from here if I take x common, I am left with only 3. Now in the second, these 2 terms, 2 is common because 2 is the highest common factor of 4 and 6. So 2 times 2 will give me 4. So 2y plus 2 times 3 will give me 6. Now if you see your first term and the second term, you can see 2y plus 3 is common in both the term. So now I will take 2y plus 3 as common. So what will happen in the first term, if I take 2y plus 3 common, I will be left with x plus, and in the second term, I will be left only with 2. So this is my factorization. Okay, so when I took 2y plus 3 common, I am left only with x, which I have written here. Now, if I have already taken this 2y plus 3 commons, in the second term, I am left only with 2. So this is the factorization of the given expression. Now another one, 6xy minus 4y plus 6 minus 9x. So here also if you can see, you will not able to find any common factor in all the 4 terms, isn't it? So what I am going to do, I am going to arrange it in such a way that I will have some common factor. So I am going to rewrite it as 6xy minus 4y minus 9x plus 6. So if you can see the first 2 terms, 6xy and minus 4y, I can see y is common, and even highest common factor of 6 and 4 is 2. So I can take 2y common over here. So let's take 2y common. So if I take here 2y common, so I will be left with 2 3s are 6, 3x minus 2. 3x minus 2 will be the left out expression here because I have taken 2y common. Now if you see minus 9 and 6. So from here you can see 9 and 6, the highest common factor is 3. 3 table both 6 and 9 come. So I can take minus 3 common. So if I take minus 3 common, I will be left with 3x. Now in minus 3, how much I will multiply to get plus 6? So it will be minus 2. So now if you see your both the terms, isn't it? So 3x minus 2 is common here also. And it is here also, right? It is present in both the place. I can take 3x minus 2 as common. So 3x minus 2, if I take common from the first term, I will be left with 2y. And in the second term, it is minus 3. So this is the factorization of the second algebraic expression given over here. Now I'm going to solve the exercise 12.1 question. So question number 1. Find the common factors of the given terms. First one is 12x and 36. So you have to find the common factor which is there present in both the terms. So let's write 12x in terms of product of the irreducible factors. So 12x, 12 I can write as 4 into 3, 4 further I can write as 2 into 2. So 2 into 2 into 3 into x. And 36 I can write as 4 times 9. 4 I can write as 2 into 2 and 9 I can write as 3 into 3. Now you have to find what are the common factors which is present in both. So you can see 2 and 2 is present in both. Again one more pair of 2 and 2 is there and then one more pair of 3. So from here I can write common factor will be 2 into 2 into 3 which will give me 2 into 2 4, 4 into 3 12. So I am writing here common factor in short as CF. Now next question 2y. So 2y I can write as 2 into y and 22xy I can write as 2 times 11 into x into y. Now you can see 2 and 2 is common and then y and y is common here. So the common factor will be 2 into y which will give me 2y. Third one 14 PQ. So 14 I can write as 2 into 7 and PQ I can write as P into Q. Next 28 P square Q square. So 28 I can write as 4 times 7. 4 further I can write as 2 into 2 and 7 will be as it is a prime number. Now P square is P into P and Q square is Q into Q. Now the common factor will be 2 and 2 is common and then P and P is common and one pair of Q is also common. So the common factor will be 2 into 7 is also common. 2 into 7 into P into Q. So it will give me 2 into 7, 14 PQ. So this is the answer for the third one. Now fourth one, 2x we can write as 2 into x. 3x square I can write as 3 into x into x and 4 I can write as 2 into 2. But I am not able to find any common factor which is present in all the three terms because 2 is present in only in the first and the last term. X is present only in the first term. So I'm not getting any common factor. But you know that 1 is the factor for all the numbers. So if you are not getting any common factor means the common factor will be 1 because 1 is the factor for all the numbers. From here I can write the common factor is 1. Now fifth question 6ABC. So 6 I can write as 2 into 3. So 6ABC can be written as 2 into 3 into A into B into C. Next is 24AB square. So 24 I can write as 4 times 6 and 4 I can write as 2 into 2. 6 I can write as 2 into 3 and then AB square. So A into B into B. Next is 12A square B. 12 I can write as 4 times 3. So 4 is 2 into 2 times 3 into A into A into B. Now let's find the common factor. So 2 is a common factor is also a common factor. Then A is also one pair of common factor. B is also a common factor. That's all. So the common factor is 2 into 3 into A into B. So this will give me 2 3s are 6. So 6AB is the common factor. Now sixth one, 16x cube. So 2 times 8. So 2 times 8 will be 2 into 2 into 2. X cube. X into x into x. And minus 4x square. 4 I can write as 2 into 2. And x square will be x into x. Now 32x. 32 I can write as 2 to the power 5. So 2 into 5 times 2. 3, 4, 5 times x. Now let's see the common factor. So one pair of 2 is common. Another pair of 2 is also common. And then one pair of x is common. So the common factor will be 2 into x. So it will be 4x. Next, seventh one is 10pq. So 10 I can write as a product of 2 and 5. So 2 into 5 into p into q. Then 20 qr will be 2 times 10. So 2 into 5 into q into r. Then 30 rp. So 2 in 2 times 15. So 2 times 3 into 5 into r into p. Let's see the common factor. So 2 is common. Is there any other common factor? 5 is also common. So from here I can write the common factor is 2 into 5, which will give me 10. Now eighth question, 3x square y cube. So it will be 3 into x into x into y into y into y. Now 10x cube y square will be 10 I can write as 2 into 5 x cube x into x into x into y square will be y into y. And the third term is 6x square y square z. So 6 I can write as 2 into 3. X square I can write as x into x. Y square I can write as y into y and z as into z. Now what are the common factors? So if I see in the numbers, nothing is common. So x is common over here in all the three terms. Again, one more pair of x is common. Then one pair of y is common in all the three terms. And then there is one more pair of y which is common. So from here I can write the common factor will be x into x into y into y. So it will be x square into y square. So this is the common factor. Now if you can see the question like the eighth one, isn't it? So first you can use the HCF method also, like 3, 10 and 6. The highest common factor will be 1. Isn't it? Because apart from one table, 3, 10 and 6 will not come in any other table. All the three numbers will not come. Now to find the HCF of the variable. So the variable which is having the lowest power will be the HCF. So if you see the power of x is lowest power of x is 2. And if you see the same way the variable y, in that also lowest power of y is 2. So that's why you can see the common factor I got as x square into y square. So this is question number 1. Next we will do question number 2. Now question number 2. Factorize the following expressions. So to solve these type of question, I will be using the HCF method. So I will find the HCF of the number separately and the variable separately, and I will do. So first find the HCF of 7 and 42. So the HCF of 7 and 42 is 7. So from here I can write 7 will be the common factor And as variable x is only in the one term, so we cannot take any variable common. So it will be 7x, 7 times x minus 6. And you can see 7 times x will give me 7x, 7 times 6 is 42. So this is the factorization of the given expression. Now second one, 6p minus 12q. Again you see the highest common factor of 6 and 12 is 6 only. And variable p and q both are different in both the terms. Nothing is common in variable, so the common factor will be only 6. So it will be p minus 2q. And you can multiply, you can see 6 times p is 6p, 6 times 2q is 12q. So this is the factorization. Third one, the highest common factor of 7 and 14 is 7 itself. Now the variable a is present in both the terms. So you have to see the variable which is having the lowest power, that will be the common factor. So the lowest power of a is 1 in the second term. So that will be the common factor. And if I take 7a common, so from the first term I will be left only with a, and from the second term I will be left with 2. So this is the factorization. Now in the fourth question, if you see the highest common factor of 16 and 20. So in fourth table both 16 and 20 comes, and that is the highest common factor. And if you see the variable, here is z, here is z cube. So the lowest of power of z is 1. So the common factor will be 4z. If I take 4z common, in the first term I will be left with minus 4, and in the second term it will be 5z square, because 4 times 5 will give me 20 and z into z square will give me z cube. Now the fifth question, the highest common factor of 20 and 30 is 10. And you can see variable L and M both are present in both the terms. So you have to see the lowest power of the variable. So the lowest power of L is 1, lowest power of M is also 1. So 10 LM will be common. So from the first term, if you take 10 LM common, you will be left with 12, because 10 into 2 will give 20. And the second term it will be 3A. Now from here I can take the highest common factor of 5 and 15 will be 5. And variable x and y is present in both the terms. So lowest power of x is 1 and the lowest power of y is also 1. So 5xy is common. So I am left with x in the first term. 5xy into x will give me 5x square y, minus 5 times 3 will give me 15, and minus 3y. So it will be 5xy into x minus 3y. Now question number 7. It is 10a square minus 15b square plus 20c square. So from here you can see it is having 3 terms. So find the HCF of 10, 15 and 20. So 10, 15 and 20, the highest common factor is 5. And if you see the variable, so all the 3 terms are having different variables. So from variable nothing will be common. So the highest common factor of 10, 15 and 20 is 5. So that will be only common. So 5 times 2 will give me 10. So 2a square. 5 times 3 will give me 15. So 3b square. And 5 times 4 will give me 20. So 4c square. So this is the expression. Now next question is minus 4a square plus 4ab minus 4ca. So you can see in all the 3 terms 4 is there. So 4 will be the common factor, and in the variable a is present in all the 3 terms. So the lowest power of a will be the common factor. So from here I can say that 4a will be common. So from the first term I will be left with minus a. From the second term it will be plus b, and from the third term it will be minus c. So this is the factorization. Now next is x square yz plus y square z plus xyz square. In all the 3 terms, the variable xyz is present. So the lowest power of the variable you have to take. So lowest power of x is 1, lowest power of y is also 1, lowest power of z is also 1. So the common factor will be x, y, z. So from the first term, if you take x, y, z, here is x square. So 1 x will be left out. Second term y square, so 1 y will be left out, and from third term z square, so z will be left out. So this is the factorization. And this is the last question. If you can see here, the variable x and y is present in all the terms. X and y is here also, here also, here also. So take the lowest power of x and y common. So lowest power of x is 1, lowest power of y is also 1. So from the first term, if I take xy common, I will be left with ax. From the second term, it will be Vy, and from the third term, it will be Cz. So this is your question number 2. Now question number 3, factorize. So first one is x square plus xy plus 8x plus 8y. So you can see you will not able to find any common factor which is present in all the 4 terms. So it means you have to use the regrouping. So let's make a group of it. So if I make a group of the first 2 terms, so I can take x common, and in the second 2 terms I can take 8 common, isn't it? So I can write it as, if I take x common from here, I will be left with x plus y, and if I take 8 common in the other 2 terms, I will be left with also x plus y. From this 2 term I have taken 8 common, from these 2 terms I have taken x common. Now you can see in both the terms x plus y is common. So I can take x plus y common. So from the first term, if I take x plus y common, I will be left with x, isn't it? From this, if I'm taking x plus 1 common over here, so I'm left only with x. Same way from the second term, already I've taken x plus 1 y common, so I'm left with only 8. So it will give me x plus 8. So this is the first question. Now the second one, 15xy minus 6x plus 5y minus 2. So if you take the, again you can see in all the 4 terms nothing is common. So again you have to do regrouping. So if you take the first 2 terms, you can see x is common, and 15 and 6 highest common factor is 3. So you can take something common from here. So let's do it. So it will be 3 will be the highest common factor of 15 and 6, and then x is also common. So I can take from here 3x common. From this 2 term I have taken 3x common. So I will left with 5y minus 2. 3x into 2 will give me 6x. Now if you see the second term, this is also 5y minus 2. So I can take 1 common. So it will be 5y minus 2. Now from both the term you can see 5y minus 2 is common, isn't it? So if I take 5y minus 2 common from both the term, so from the first term I am left with only with 3x, and from the second term I am left with plus 1. So it will be 3x plus 1. Now for these type of factorization, actually you have to do more and more practice. Then only it will click in your mind fast when you are solving it, and it is very interesting also. So once you understand it properly, you will get a lot of interest and you will feel like solving more and more questions. Now the third one is ax plus bx minus ay minus by. So here if you can see, from the first 2 terms, I can take x common, and from the last 2 terms, I can take minus y common. So I can write it here as x common, so it will be a plus b, and here I am taking minus y common, so it will be also a plus b. Now when there is a minus, you have to be very careful. Minus y into a will give me minus ay, and minus y into plus b will also give me minus by. So from here I can say a plus b is the common factor now in both the terms. So I am left with x minus y. How x minus y I got? So from the first term, if I am taking a plus b common, I am left with x. Second term I have already taken a plus b common, so I am left with minus y. So this is the factorization. Now fourth question, 15pq plus 15 plus 9q plus 25p. So from the first 2 term I can see that 15 is common. So if I take 15 common, I will be left with pq plus 1. And in the second term I am not getting anything common, isn't it? So I cannot group like this whatever order is given as 2 terms. So I have to do little rearrangement. So what I can do, I am going to write it as 15pq plus 9q. So here also my q is common, and HCF of 15 and 9 I can get as 3. And then I am writing 25p plus 15. So from the first 2 term I can take 3q common, because the HCF of 15 and 9 will be 3. And q is present in both the terms. I have taken 3q common. So I will be left with, in the first term, if I am taking 3q common, I will be left with 5p plus, and 3 times 3 will give me 9. So 3q into 3 is 9q. Now from the second last 2 terms, you can see, you can take 5 common. So it will be 5p plus 3. Now you can see 5p plus 3 is common in both. So you can write 5p plus 3. If you take common, you will be left with 3q plus 5. Next, this is the last question. Z minus 7 plus 7xy minus xyz. So here also I am going to do little bit of rearrangement. So I am doing z minus xyz minus 7 plus 7xy. Now see, there are more than one ways of regrouping and you will get the same answer. So it's up to you. So this is my one of the methods. If I take z common, so from the first two term I will be left with 1 minus xy, isn't it? Z into 1. Z into 1 will give me z, minus it will be here, and then z into xy is xyz. Now next I am going to take minus 7 common. So if I take minus 7 common, I will be left with 1 minus xy. So minus 7 into minus xy will give me plus xy. Now I can take 1 minus xy common as it is present now in both the terms. So I will be left with z minus 7. So you can see here if I have taken 1 minus xy common. So from the first term I left with z, second term I left with minus 7. So this is the algebraic expression. So that's all for today's class, and if you like my video, please subscribe my channel and share with your friends also. Thank you.